A proof without words is a geometric diagram that proves some kind of formula and that doesn't require using numbers or variables. And some of the best proofs in math can be done with these proofs without words. We're going to look at formulas for finite sums that utilize proofs without words. 1, 2, 3, 1 plus 2 plus 3 plus 4 plus 5 is the sum of 5 consecutive integers, and it equals 15. 1 plus 3 plus 5 plus 7 plus 9 is the sum of the first 5 consecutive odd numbers. It equals 25. 1 plus 4 plus 9 plus 16 plus 25 is the sum of the first 5 perfect squares. They add up to 55. 1 plus 8 plus 27 plus 64 plus, that should say 125 instead, is the sum of the first 5 cubes, and it equals 225. We're going to see what there are formulas for these, for adding up the first n consecutive integers or consecutive odd numbers or consecutive squares or consecutive cubes. A more general way of writing this is seen on this page, where I go not just 1 plus 2 plus 3 plus 4 plus 5, but up to just n. And then I wrote it with the summation notation on the right-hand side. That doesn't at all help you get the formula for it, but that's just a shorter way to write that. The solutions to these proofs without words will be presented in other videos, but for now, the first two proofs without words are proving this formula here, that the sum of the first n integers is 1/2 n times n plus 1, proving in the second picture that the sum of the first consecutive odd numbers is equal to n squared. Here are two different ways of proving that the sum of consecutive squares adds up. One way of writing it is this. Another way of writing it is this. In general, the formula is often written as n times n plus 1 times 2n plus 1 over 6. These are all equivalent to that. And finally, the big one, the sum of the first n perfect cubes, according to this formula, add up to the sum of the numbers and then squaring that. Back to this page, we can actually test the formulas. So for the first one, according to the formula, it's n times n plus 1, that's 5 plus 1 over 2, is 5 times 6 over 2, which is 15. So at least it works for that example. The second one claims that this is the fifth term, so it claims that it's just 5 squared, which is 25, so that formula seems to work. For the sum of the first 5 squares, according to the formula, it's 5 times 5 plus 1 times 2 times 5 plus 1 over 6, which is 5 times 6 times 11 over 6. 6 is canceled. It does become 55, like we hoped. And finally, for this one, the sum of the first 5 cubes, according to the formula, is 5 times 5 plus 1 over 2, and that whole thing squared, which is 15. That 15 is the same 15 from over here squared, which is 225. Now that doesn't prove that these formulas work, but it at least suggests that they probably work. Your assignment is going to be to look at these 2, 3, 4, 5 proofs without words and see if you can tell how it is that they give a proof for these summation formulas.